Hi everyone, I am Dr. Subbarao from RVIT Institute of Technology. In this video, I am going to explain Unit 2 Modern Engineering Materials. This Unit 2 Modern Engineering Materials covers semiconductors, introduction, basic concept and applications. Superconductors, introduction, basic concept and applications. Supercapacitors, introduction, basic concept, classification and applications. Nanomaterials, introduction, classification, properties and applications of fullerenes. Carbon nanotubes and graphene's nanoparticles. Coming to the first one, modern engineering materials introduction. The electrical engineering materials. The electrical engineering materials mainly classified into three categories by depending upon the ability of a material to conduct electricity. They are conductors, insulators and semiconductors. The first one is the conductors. The materials are a substances or an electrolytic solutions which allow the passage of electric current through them are known as electrical conductors. So conductors are the materials which conduct electricity. Basically, the conductors do not oppose the flow of electric current or flow of charge. So the flow of charge is called the current. So the materials which conduct electricity are known as electric conductors. For example, all the metals like aluminum, copper, silver, gold, etc. So these are the metals having the electrical conductivity. And the next one is the semiconductors. Semiconductors are the materials which are having the electrical conductivity in between the conductor and the insulator. So the conductance of the material having the in between the conductor and the insulator. So such kind of materials are known as semiconductors. For examples, silicon, germanium, gallium and gallium arsenide. So these are the examples of semiconductors. These semiconductors are also defined as the materials which behaves as insulators at absolute zero and conduct electricity at normal temperatures are known as semiconductors. That means if you condense the materials, that means if you decrease the temperature of the material, it behaves as an insulator. And if you raise the temperature of the material, then it conducts the electricity. Such kind of materials are categorized in semiconducting materials. Next, third one is the insulator. So insulator means the materials which resist or which does not allow the passage of electric current through them are known as insulators. That means these are not allowing the electricity to pass along with them. For example, rubber, silica, mica, glass, PVC. So these are the examples for insulators. Now, what is electric conductance or conductivity? So what is the difference between the conductance or conductivity and the conductor? So coming to the definition of conductance or conductivity, the electrical conductance is a measures the material's ability to conduct the electricity. That means this one conductance is the ability of a material to conduct electricity. So it is represented by the letter capital G, and it is also defined as the reciprocal of the resistance of the material. That means G equals to 1 by R. 1 by R means the reciprocal of the resistance. So it is also defined as the reciprocal of the resistance is called conductance or conductivity of the material. And the units for conductivity is ohm inverse. And the next one is the Conductors. Conductors are the materials which conduct electricity. So these are the electrical wires, all are the comes under the conductors. Here the aluminum and copper are used for the electrical conductors, and is the insulation wires. These insulations are the backlights are PVC. These insulation covers are the insulators. And the next one, what is resistance? So the resistance is a property of material that opposes the flow of electrical current. That means the resistance is the property of material which does not allow the flow of electric current. That means which stops the electricity. The units for resistance is ohms. Ohm is the unit for resistance. Now coming to the factors that are influence the resistance. So these are the main factors that influence the resistance. The first one is the length of the conductor. The resistance offered by a material is directly proportional to the length of the conductor. That means if the length of the conductor is increases, then the resistance of that material is also increased. And if you reduce the length of the material, then the conductance of the material also decreases. So this is the directly proportional. That means the R is the resistance R is directly proportional to L, where L is the length of the material. This one is considered as equation 1. And the next one is the area of cross section. That means the resistance offered by a material is inversely proportional to its area of cross section. That means if the area of the material increases, then the decrease of the resistance is observed. And if the area of cross section is decreases, which means it has the more resistance. So this one is represented as R is inversely proportional to A. That means R is directly proportional to 1 by A. This is considered as equation 2. From this equation 1 and 2, the R is directly proportional to L by A. Here we remove this proportionality and introduced some constant here. So R is equals to rho into L by A. Here this rho is the proportionality constant. We call it as a resistivity. So here R is the resistance of the material and rho is the resistivity of the material, and L is the length of the material, and A is the area of cross section. Now what is the resistor? So resistor is the material which opposes the flow of electric current. Resistance is the property of material, and resistor is the material which opposes the flow of electric current. This one is the difference between resistance, resistor, and the next one here the resistivity. What is the resistivity? We have to know about the resistivity. The resistivity is a fundamental property of material that quantifies how strongly it opposes the flow of electric current. This is the resistivity of the material. And we know that the resistance of a material R is equals to rho into L by A. From this equation, rho equals to R into A by L. This is the formula for resistivity. So the resistivity rho equals to RA by L. This is the formula for resistivity. And now units for resistivity. The units for resistivity is ohm meter. This is the representation of ohm meter. Thanks for watching. If you like this video, please like, share and subscribe. Please click the bell icon symbol for more informative videos. Thanks for watching.